All right, we got two more examples to look at, and this time we're going to apply the Pythagorean identities. So here's some up top that you should recognize over time, become very familiar with. The fact that sine squared x plus cosine squared x equals 1, which the purple and the blue and below it all come from that identity. Because of that, we can say the sine squared of x is equal to 1 minus the cosine squared of x just by subtracting cosine squared x on both sides. And the same thing with cosine squared x. We could have subtracted sine squared x on both sides to get those identities. In the other identity, tan squared x plus 1 is the same as secant squared x, which means through algebra we can write a couple different ones. And the last one in green is 1 plus cotangent squared x is equal to cosecant squared x. So let's look at a couple examples and let's use them to solve. So you always want to, in the first hot tip I gave you, you always want to try to write everything as sine and cosine. Another thing you want to look at is a look for an identity. Okay, these are all the identities I have been giving you. I gave you the negative identities in the last examples. Now I'm giving you the Pythagorean identities. So let's rewrite these. We know that 1 minus cosine squared x equals sine squared x. So we can say that we have sine squared x over cosine squared x equals tan squared x. Well, we know that sine squared over cosine squared is tan squared. So that's how easy the first one is. We just proved it by saying that the tan squared x equals tan squared x. I apologize. I'm using a mouse to write right now because the pen's not working. All right, but now let's look at a little bit more difficult problem. But before we do that, I want you to take a look at something very similar to help us. If I had x squared plus 2x plus 1, we know that that can factor to x plus 1 times x plus 1. Okay, we did that. I don't even remember what unit it was. I think it was unit 8. I'm not even sure, but we've done that factor, right? We're going to use this property for the sine squared x plus 2 sine x plus 1 because it's the same thing. So we're going to rewrite this as sine x plus 1 times sine x plus 1 over cosine squared x equals 1 plus sine x over 1 minus sine x. Okay, so we're getting there. And that's where the hot tip number 3 was, which was to use algebra to make equivalent expressions. All right, well, what do we know about cosine squared x? Okay, we should know that cosine squared x is the same thing as 1 minus sine squared x. So we can now rewrite this as the top we already had, sine x plus 1 times sine x plus 1 over, what did we say? We said 1 minus sine squared x. And I'm not going to rewrite the other side. Actually, you know what? I will. Equals 1 plus sine x over 1 minus sine x. Well, if we continue to focus on the bottom, we can rewrite the bottom as, let's see, 1, that's a difference of 2 squares. So now we can rewrite this as sine x plus 1 times sine x plus 1 over 1 minus sine x times 1 plus sine x. All right. Well, and we know that equals 1 plus sine x over 1 minus sine x. So we followed all our hot tips. We've rewritten things in terms of sine and cosine. We've looked for identities. We've used algebra to make equivalent expressions. what I see is that sine x plus 1 is the same as 1 plus sine x, so I can cancel those.